I am S.B Mishra, going to teach you some extra problems of chapter 1. These problems have been kept for you for practice purpose. These questions are not necessary for examination point of view. First question. So that the square of any odd integer is in the form 4q plus 1. Answer. We know that 2q plus 1 is odd integer. Just see here, select n is equal to 2q plus 1 is odd. The proof of this fact is available in question number 2 of page 2. In page number 2 I have already proved that 2q plus 1 is odd number. So this 2q plus 1 is taken for this purpose. Why 2q plus 1? Because a square of 2 will give you 4. Now 2q plus 1 is odd number. Now a square of this odd number 2q plus 1 ka whole square is equal to 2q ka whole square plus 2 into 2q into 1 plus 1 whole square, a square plus 2ab plus b square. So this is 4q square plus 4q plus 1. From first two terms take 4 common. So 4 into something plus 1. This bracket is taken as q. So 4q plus 1 form. Whatever inside the bracket, you can name it q. Or any name you can create. 4m plus 1 you can say, 4q plus 1 you can say. But here the requirement is 4q plus 1. So the bracket is taken as q, 4q plus 1. Now the second question. Prove that n square minus 1 is divisible by 8. Again you have to, where n is odd number. This is divisible by 8 if n is odd. Or you have already known that select n is equal to 4q plus 1, n is equal to 4q plus 3. Both are odd numbers. The proof of this, the fact is available in question number 3 of page 3. I have already proved that 4q plus 1 is odd, 4q plus 3 is odd. So case 1, if 4q plus 1 is taken as n, then n square minus 1, 4q plus 1 whole square minus 1. Simplify it, a square plus 2ab plus b square. 1 cancelled. So 16 cube square plus 18q. 8 common. 2q plus 1, 2q square plus q inside the bracket. Since 8 is outside, so it is divisible by 8. 8 is a factor, so divisible by 8 is proved. Case 2, let n is equal to 4q plus 3. Try yourself. Third problem. Prove that the square of any positive integer cannot be in the form 5q plus 2 or 5q plus 3. A is equal to bq plus r, well known to you. Now 5 is the requirement, so b is equal to 5 is taken. So a is equal to 5q plus r, where r is equal to 0, 1, 2, 3, 4. A squaring is needed, so squaring this, a square is equal to 5q plus r ka whole square. So a square plus 2ab plus b square. So we are getting a square is equal to 25q square plus 10qr plus r square. Now if r is equal to 0, let this is 1. So putting r is equal to 0 in 1. A square is equal to 25q square. R is 0, so this term is 0, this term is 0. This is 25q square is neither in the form 5q plus 2 nor in the form 5q plus 3. This is nor. N-O-R, nor. Yes. Now put r is equal to 1. Then a square will be, if 1 is taken here, 10q into 1, 10q. 1 whole square, 1. So this is 25q square plus 10q plus 1. 5 is taken common from first two terms. This is 5q plus 1 form. And never in the form 5q plus 2 or 5q plus 3, which was the requirement. 5q plus 2, 5q plus 3. No. It is in the form 5q plus 1. Similarly, we can try for another values of r is equal to 3, 4. 3, 4, 2, 3, 4. 0, 1 have been shown. 2, 3, 4 you can try. Similarly. Now fourth number. This is very small and important question. Find the largest number which divides two numbers, leaving the remainder 5 in each case. You must have answered this type of question in class 6. The remainders are being subtracted from two numbers. We are getting this. Now the required number, the required largest number is HCF of 240 and 1024. And you know how to find HCF 16. Obtain yourself. Fifth number, out of three consecutive positive integer n plus 1 n plus 2, only one is divisible by 3. Now we know that a is equal to bq plus r, but we have to tackle n. So let n is equal to bq plus r, and since the 3 is the requirement, divisible by 3, so b must be 3. So n is equal to 3q plus r. Now remember it that when we put r is equal to 0, then this n will be 3q plus 0. This is 3q. 3q is divisible by 3. But we have to test n plus 1, n plus 2 at the same time. In first case, n is tested. Now n plus 1, adding 1 both sides in this. n में 1 add किए, n q plus 1 में भी again 1 is added in right side of this. 3q plus 1 is never divisible by 3. This contains 3, this does not contain 3. Now 3q contains 3, but 1 does not contain 3. Now adding 2 both sides, so n plus 2 is equal to 3q plus 2. This is also not divisible by 3. So out of the two things, n plus 1, n plus 2, only 1 is divisible by 3. Proved. If r is equal to 1, then n is equal to. If r is taken as 1 in this, 3q plus 1 will come, n is equal to 3q plus 1. Again, this is not divisible by 3. When 1 is added both sides, n plus 1, 3q plus 1 plus 1 more. This is 3q plus 2. This is also not divisible by 3. Adding 2 both sides in this, n plus 2 is equal to 3q plus 1 plus 2. This is 3q plus 3. When 3 is taken common, inside the bracket 3q plus 1 is left, which is divisible by 3, because 3 is a factor outside this bracket. Hence, in the second case, out of the 3 members, only 1 is divisible. If r is equal to 2, again n is equal to 3q plus 2. For r is equal to 2, n is equal to 3q plus 2, not divisible by 3. Adding 1, 3q plus 2 plus 1, 3q plus 3, again 3 common. We are left with q plus 1. This is again divisible by 3. Now here is a problem. This 3 should be replaced. This should be cancelled. This is simply q. 3q plus 3. Yes. Now when r is equal to 2, n is equal to 3q plus 2. Not divisible, n plus 1, adding 1 both sides, 3q plus 3. When 3 is common, q plus 1 is divisible by 3. Adding 2 both sides, again 3q plus 4 is not divisible by 3. So out of the 3 members, only 1 is divisible by 3. Now come to 6th number. Find the largest number which will divide this leaving remainder 7, 11, 15. Again remainders are being subtracted, and we are getting the 3 numbers. Find HCF of 3 numbers. This will come 17. Find yourself. How to find HCF is known to you. Now, question number 7. This is high order thinking problem. High order thinking. Note it that high, HOTS, high order thinking, a skill problem. So HCF of this and this is in the form this 56x plus 72y. Express this and also find xy, so that xy are not unique. It means there may be many values of x, many values of y. You know HCF of this and this is 8. So first of all we have obtained HCF of 56 and 72 1. This is 8. The first part of problem is over. Now according to question, a by q, according to question shortcut. This 56x plus 72y is equal to 8 given, that HCF of this and this is this. Now 8 is common everywhere, so to read the table of 8 and cancel. 8 7 ja 56 and 9 8 ja 72, 8 1 ja 8. This is in simplest form. This is an equation in simplest form and one equation with two variables. This is one equation with two variables, so infinitely many solutions, infinitely many values of x and y will appear. So not unique. Not unique means there will be many x's, many y's. There is one equation with two variables, many answers of x and y will come. Now solving one. How to solve this? Just see. 7x is equal to 1 minus 9y. So x is equal to 1 minus 9y by 7. Now know it that you have to select y in such a way, y is equal to starting from 0. And select y in such a way that the whole right side expression is divisible by 7. So the value, the right side this should be, if you have to select y, start from 0, then 1, then 2, then 3, 4, 5, so on, and get the multiple of 7. Denominator is 7, so try to get the multiple. For y is equal to 4, 0 not applicable. Likewise, if y is equal to 4, 7 4 ja, so y is equal to 4, 9 4 ja 36, 1 minus 36 by 7, minus 35 by 7, thus x is equal to minus 5, get y is equal to 4. So we have expressed and we have obtained xy. Also find xy. The M is over. Good luck.